All right, we're on question 86 of our notes. We've been learning about how molecular attraction and kinetic energy interact to determine the phase, whether something is a solid, liquid, or gas. But we have not actually yet defined molecular attraction. We talked about it in chapter 2. We read a bunch about it in the liquid oxygen article, but we have not written it down for our vocabulary term. So, question 86 is the definition of molecular attraction. The definition is a pull between two molecules that is always the same for a substance. Pause this and write it down. So here we've got the image from our article. It says substance A and B have molecular attractions that pull their molecules together. So A was weak, so they're not pulled together very strongly. B's was strong, so they're pulled more tightly together. So pause, make sure you get this written down. And we'll move on to key concept number 9. Question 87 is key concept number 9. This says whether or not a phase change occurs is determined by the interaction between the kinetic energy of the molecules and the attraction pulling the molecules together. Remember in the article it's talking about a tug of war between the kinetic energy and the attraction. That is what this key concept is about. So pause this, write this down. Okay, so if the kinetic energy wins over the attraction, that means we're gaining freedom of movement and we're either going from a solid to a liquid with melting, or we're going from a liquid to a gas with evaporation. If the reverse is true and the attraction is the one becoming stronger than the kinetic energy because you're losing kinetic energy, then that means we're losing freedom of movement. We're removing kinetic energy, and the kinetic energy becomes weaker than the attraction. So we either go from a gas to a liquid, which is condensation, or we go from a liquid to a solid, which is freezing. Key concept number 10. This is question 88 in your notes. This key concept says the molecular attraction of a substance never changes for that substance. Pause the video and write this down, and then we'll talk about it. Okay, so this means that you cannot change the molecular attraction for a substance. So on the quiz that we had, there was a couple questions that talked about changing the molecular attraction in order to cause something to become a solid, liquid, or gas. That is not possible to do. You cannot change the molecular attraction. It is always the same for any given substance. Water has a specific molecular attraction, and that never changes. Gold has a specific molecular attraction, and that never changes. Same for diamonds, same for rubbing alcohol, same for oxygen. They all have a different molecular attraction, but for those single substances, that level of attraction never changes. Okay, going back to the marble activity. Remember, we had marbles in a tub, and those represented weak magnets, which are weak molecular attraction. It is easy to turn these into a liquid or gas. You don't have to add a lot of energy to break them apart to give them more freedom of movement. But if we had stronger magnets, that would represent a stronger molecular attraction. If those magnetic marbles were incredibly strong and really drawn together, it'd be harder to break them apart to give them more freedom of movement. So when there's stronger molecular attraction, it's harder to turn into a liquid or gas. You have to add lots of energy to break them apart and give them more freedom of movement. Okay, last thing in this video is we're going to talk about a question from quiz 2. We actually removed it from this year's quiz, but it was a difficult question from quiz 2 last year, so I figured I'd talk about it. The question was true or false. For a single substance, the freezing point, which is the temperature that a substance freezes at, is the same as the melting point, the temperature that a substance melts at, because the molecular attraction doesn't change for any given substance. So I want you to pause the video and think about this and read it again and come up with an answer. What do you think the answer to this question is? Okay, so the answer for this question should be true. The freezing point is always equal to the melting point for any given substance. So imagine water. Let's say water has a molecular attraction right here. Its molecular attraction is never going to change. It's not going to increase in energy. It's not going to decrease in energy. It's always going to be right here. The only thing that changes is the temperature and the kinetic energy. So let's say water has more kinetic energy than its molecular attraction. If it has more kinetic energy, that means it has broken the molecular attraction and it is a liquid. As we remove kinetic energy, it hits this point, and at this point, the molecular attraction wins, and the water goes from a liquid to a solid. And now it has less kinetic energy than the molecular attraction, so the molecular attraction has won that tug of war. Let's imagine a different scenario where we start with a solid. We have very little kinetic energy. Remember, our molecular attraction does not change. It's still here for water no matter what. Now we're adding energy. It's solid, it's solid, it's solid. It hits this spot where the molecular attraction for water is and then goes above it, and now we're a liquid. So the melting point and freezing point for water is always the same because this level of molecular attraction is always the same. It never changes. So the answer to this question here is true. The freezing point of any substance will always be the same as the melting point for the substance. And the reason that that is the case is because the molecular attraction does not change for a single substance.